Okay, in this video we're going to work out some compound interest questions. In question 1, Rosemary has $25,000 to invest for 5 years. She considers the following options. So there's 4 options, and in each option you'll notice there's a different interest rate and there's a different compounding period. So for the first one it's 1 year, the second one it's compounded quarterly, so 4 times a year. The next one compounded monthly, 12 times a year. This one compounded daily, 365 times a year. Okay, so those are going to be the important numbers in each of the 4 different situations. Let's set them all out. Okay, now the principal amount, $25,000, is going to be the same for all options, and the amount of time, 5 years, is going to be the same. But in each case it's going to be different because of the different compounding periods, what the number n is. So what we want to write down is the interest rate for each of these different scenarios. We're going to need that. So that's going to be 6.75, 5.15, 5.3 and 6.4. For the n, the number of compounding periods, that's going to be, for the first one, annually for 5 years, so there's going to be 5 compounding periods. For the second one, it's compounding quarterly for 5 years, so quarterly means 4 times a year. 4 times a year for 5 years is going to be 20. For the third one, it's compounding monthly for 5 years, so that's going to be 12 times 5, which is 60. And there's 60 compounding periods. And for D, it's compounding daily, so n equals 365 days a year for 5 years. We're going to have to put that into a calculator. Let's go 365 times 5 gives us 1825, and it says to consider that there's 1 leap year in the 5-year period. So if we had 1825 days, we'd add 1 onto that for that 1 leap year that's going to have 1 extra day in it. So just add on 1 to 1825, we get 1826. Okay, so this is the information we're going to need to put into the calculator for each of the different scenarios in order to get the amount of interest we're going to earn on each for each one. Well, actually the calculator is not going to give us the interest, it's going to give us the amount, which is going to be the interest plus the principal. So let's change those to A. Alright, let's put them in. For the first one, to do these we're going to go to menu and we're going to go to the financial calculator here. And it straight away comes up with compound interest, but if it didn't come up straight away, we just go to calculations, compound interest, there it is. And let's bring up this help box. That helps us to know what we've got to put in each of these tabs. So for the first one, we've got to put the number of installment periods, okay, which is n. For the first of our situations, n is 5. The interest rate is 6.75. The principal amount is 25,000. That's going to be the same for all of them. Amount paid each period, we're going to leave that for 0 for all of these. It'll be relevant to other situations, but it's not relevant in this one. We're going to leave it as 0. We're not paying anything each period. The future value, that's what it's going to calculate for us, the amount that the investment will become in the future, and the number of installment periods per year. For the first situation, there's only 1 installment period per year, and the number of times interest is compounded per year is also 1. So we'll set both of those to 1. And then we want to calculate the future value, so we click on that future value button there and it brings up this amount here. Notice it's got a negative sign there, we just ignore that. I don't know why it puts a negative sign there. 34,656 and 8 cents. 34,656 and 8 cents. So that's what the first investment will give us. That's 25,000 plus the interest will give us that amount. Alright, for the second one, the compounding period is now 20. The interest rate is now 5.15. all of those stay. Now this time the number of installment periods per year, it's quarterly, so there's 4 per year. Number of times interest is compounded is also 4. So we change those to 4. It says it's quarterly, which means 4 times a year. Calculate the future value. It's 322.89.18. 322.89.18. Okay, for the next one, there's now 60 compounding periods. The rate is 5.3. The number of periods, installment periods per year, is now 12 because it's monthly in this one, so we change both of those to 12, and then calculate the future value. Click on there, 32,566 and 77 cents. So 32,566 and 77 cents. Okay, and finally the last one, we've got 1826 compounding periods. 6.4 is the interest rate, and we've got 365 installment periods per year. Now we know there was one year where it was different, but there's nothing we can do about that. 365 was the one for 4 out of the 5, so that's better to put that. Okay, when we calculate that, we get 344.33, 344.33 and 26 cents. Okay, so clearly this one is the biggest one. That's going to be the best option that we should advise Rosemary to take, the first one. Okay, in question 2, Warren wishes to invest $10,000. He's got 4 investment alternatives. So in A, it's simple interest, and the important bits of info are the P is 10,000, the interest rate is 9%, and we're told at the end of the question, calculate his amount of his investment at the end of 7 years for each. So T would be 7 years, and so we'd be wanting to work out I. We're going to be working out I for each of these. In B, let's find the important information there. So it's compound interest this time, and P is still 10,000. It's going to be 10,000 for all of them. The rate is now 8%, and we need to know the number of compounding periods for this one. So over 7 years, and it's compounded per annum, so there's going to be 7 compounded periods. In the third one, C equals compound interest 7.5%, so P is going to be the same, we'll leave that the same. R is now 7.5%, and this is compound interest, and it's adjusted quarterly. So over 7 years, and it's quarterly, it's going to be 7 times 4, which is 28. Those are the important bits of info for that one. And then for D, compound interest 7%, so that's the same. The rate is now 7%, and it's adjusted daily. So N equals 365 times 7. Let's see what that turns out to be. 365 times 7 is 255, and in 7 years I think we could reasonably assume there'd be 2 leap years in there. You could say there'd be only 1, or it'd be up to you, but I'm going to say there's 2, so 255 plus 2 is 2557. 2,557 is the number of compounding periods. Alright, let's put these into the calculator and see what we get for each one. So we'll go to the financial section. For the first one, we've got N equals, we've got to use simple interest for the first one, so let's jump to simple interest. Okay, the number of days is 7 times 365, which it's calculated for us. The interest rate is 9%. The principal value is 10,000, and we want to calculate the simple interest is 6,300. We can just chuck this in here as well, and it gives us the 10,000 plus the 6,300. So 16,300. That's A. 16,300 is the first amount, first investment return. Alright, for the second one, let's find out what return we'd get on that. So let's go to compound interest. Now N is 7. The interest rate is now 8%. Principal value is 10,000. Payments are going to be 0, and it's going to be 1 and 1 because we're only doing one compounding amount per year. So when we calculate the future value, we get 17,138.24. 17,138.24. We should put dollar signs in front of those. Okay, so that one's a little bit bigger. For the third one, we've now got 28 compounding periods. The interest rates drop down to 7.5%, and we've got to change this to 4 and 4. Remember, these are the amount of compounding periods per year. Okay, so when we go calculate for that, we get 16,822. 16,822.61. Okay, so that one's a little bit smaller than the last one, but still bigger than the first. Finally, for the last one, we've got 2,557 compounding periods. We've got an interest rate of 7, and for this one there's 365 compounding periods per year. So we put in 365 down there, we get 16,328.66. 16,328.66. Okay, so the biggest one is this second one here. Now it's important to recognize that back here when we worked out that in 7 years there were 365 times 7 days, which gave us 2,555 days, and I added on the 2 days because I figured in 7 years there's probably going to be 2 leap years. If you pick a period of 8 years, there should be one or maybe 2 leap years in there. Sometimes you don't need to include the leap years. Sometimes you do. If it doesn't tell you whether to include them or not, then it's up to you whether to include that extra 1 or 2 days there. It is going to make a small difference in the outcome. If we had have not included the leap years, then this amount probably would have been slightly smaller. So it does make a small difference, and if it doesn't specify, then it's up to you to decide what to do about that. Okay, and this question: for each of the following, calculate the interest on the investment compounded annually, semi-annually, monthly, and daily. And we've got 2 different sort of sets of numbers to do that for here. So in the first one, A, we've got to do it annually, semi-annually, monthly, and daily. Calculate the interest gained in each of those 4 different situations. So in the first situation, annually, we're going to have N equals, in 2 years, annually, N is going to equal 2. The principal amount will equal 2,500, and R will equal 4.95. For the second one, N is going to be semi-annually, so in 2 years there's going to be 4 compounding periods, 2 each year. That's going to be the same, and that's going to be the same. In the third one, because it's monthly for 2 years, it's going to be 24, 12 months in each year. And for the last one, daily, it's going to be 365 times 2 is what's that going to be? 730. Okay, so all we've got to do is put those into the calculator, and we're going to get an amount. It's going to give us the total amount in the calculator, and once we've got the total amount, as it says here, the compound interest is the difference between the compounded amount and the principal. So we'll just have to take the principal away from the amount we get, and we'll find out how much interest was gained. Okay, so for the first one, N was 2, I was 4.95, the principal was 2,500, that was 0, and this was 1 and 1. And so when we click on FE, we get 2753.63. Okay, and for the next one, all we need to do is change N to 4, and we need to change this to 2 and 2 because now there's two installments, or sorry, two times that the interest is compounded each year. And then we go to FV again to get our new calculation, and we've got 2756.84. Okay, next we've got 24 installments, and this time 12 per year, and that gives us 2759.60. And finally we've got 730 and 365, which gives us 2760.15. Okay, now in each case we need to minus 2,500 from this amount to get the amount of interest that was gained. Okay, so I'll put those into the calculator and get the results. Okay, as you can see here, we've put those sums into the calculator, and these were the results. So it turned out that this one gave us the greatest amount of interest. So that would be the best way to do it. If it seems if you're compounding it daily, then everything else is equal, then you're going to get a little bit more money for your principal. You're going to get a little bit more interest that way. That's the advantage of the compounding interest. The more times you compound it, the more opportunities you get to build on that little bit of extra interest that you get. Okay, in this question we've got Bettina and Brendan investing $1,000 for their son on his first birthday. They placed the money in a term deposit with an interest rate of 5.2% per annum, compounded monthly. Okay, we want to work out how much the investment's worth on his 21st birthday. So our principal is obviously going to be $1,000, and R is 5.2, and N is the number of periods, the number of compounding periods during the time. So from his first birthday to his 21st, that's going to be 20 years, and it's going to happen 12 times every year because it's compounding monthly. So it's going to be 12 times 20, which is 240. And it's going to be 240. So let's put that into the calculator. Okay, when we put those figures in, 240 for the number of compounding periods, 5.2, 1,000, and 12 and 12 for the number of times each year it compounds, then we get this result, $2,822.87. $2,822.87. So after 20 years, his investment's almost tripled in its value. Okay, so in this question, it's the same idea that we've been looking at, but it looks like a different situation. We're no longer talking about loans from the bank and interest accruing, something like that. It's now talking about hospital insurance, but it's actually going to be exactly the same. Over the last 3 years, a comprehensive hospital cover from Take Care Private Medical Insurance rose at an average of 9.5% and currently costs $19.80 per year. With this rate of increase continued, what would be the insurance premium after another 3 years? Okay, so all we've got to do, as usual, is find out what our key values are. The principal amount, it currently costs $19.80 per year. That's our starting point, and it's going to, from that starting point, it's going to increase at 9.5% each year for 3 years. So principal, starting point is $19.80. The rate is 9.5%, and the number of compounding periods, it says the increase in premium compounds each year, so that's once per year. So over 3 years, once per year, it's going to be n is 3 compounding periods. So all we've got to do is put those into the calculator. Okay, so n is 3, r is, well, the percent is 9.5, the principal amount is 1980, payment 0, and that's 1 and 1. And when we do that, we get 2,599.61. So that is how much the insurance will cost in 3 years' time if it continues at that rate. Okay, so now we venture into another kind of situation. Although the mathematics is exactly the same, we're now talking about inflation, the inflation of prices of things. So in this question, we've got a motorcycle that's worth $20,000. We've got an inflation rate that is 4%, and we want to know the cost of the motorcycle after 1 year. So we've got a time period of 1 year, which means the compounding period is going to be 1. So we've got all our values, same as all the other questions. We've got our P, R, and our N. We've just got to put them into the equation to get the answer. So N is 1, I is 4, PV is 20,000, and that's 1, 1. When we do that, we find out the cost of the motorcycle is now $20,800. Okay, in question 7, an electrical guitar is priced at $850 at the beginning of 2005. So straight away, I reckon the P is going to be 850. The inflation rate is 3.3% per annum, so R equals 3.3%. And we want to estimate the cost of the guitar at the beginning of 2006. So the period of time that's passed is 1 year. And since the inflation rate's 3.3% per annum, we haven't been told anything other than it's compounding once per year, so we're just going to assume once per year, so n equals 1. Let's put that into the calculator. And we get $878.05. Okay, in the next part, it says the government predicts that inflation will fall to 2.7% in 2006. Estimate the cost of the guitar at the beginning of 2007. So this time, at the beginning of 2006, the guitar is worth now $878.05. The interest rate for the next year is going to be 2.7, and again, n will equal 1. So we just need to put those values into the calculator. $878.05 is the principal now, so we calculate that, we get 901.76. That's going to be the value of the guitar at the beginning of 2007. Okay, in question 8, we've got a litre of milk that's worth $1.70 and an inflation rate of 6%, and we want to know the cost that a litre of milk the cost of a litre of milk in 10 years time. So the number of compounding periods is going to be 10, one each year for 10 years. So we've got our P, our R and our N. Let's put them into the calculator. N is 10, I is 6, 1.7 and 1 per year for the compounds per year. We end up with $3.04 is the cost of the milk in 10 years time. Okay, in this question we've got P equals $1. We've got inflation rate is 3.4, and we want to know the cost of the newspaper in 5 years, so N equals 5, and our answer's got to be to the nearest 5 cent. So N is 5, I is 3.4, 1, and those bottom two numbers stay at 1. We end up with 1.18, but we want it to the nearest 5 cents, so that's going to be 1.20, $1.20. Okay, in these questions we have another kind of variation on the compound interest theme. We've got appreciation instead of inflation or loans from a bank, something like that. So this is how things rise in value over time. A ring bought for $240 appreciates in value by 14% per annum. So R is 14% and P equals 240. If this rate of appreciation continued, what would be the value of the ring after 25 years? So in other words, after N equals 25. Let's work it out. If N equals 25 and R is 14, the principal is 240, I think this ring is going to get pretty expensive after a few years. Click on FE. Wow, it's gone up to $6,350.86. So that's a lot of appreciation. Okay, in question 11 we've got a principal value of 250. The rate is 25 and we want to know the value of the shirt in 2017, which is 10 years later. So N equals 10 and our answer's got to be to the nearest $10. So N equals 10, I equals 25, P equals 250. So our answer is 2,328, and to the nearest $10 is going to be 2,330. Okay, in question 12 we've got a principal of 420. If the value of the wine is predicted to increase at 8% per annum, so R is 8, estimate the value of the wine in 15 years, so N is 15, and we need to have our answer to the nearest $10. So N is 15, R is 8, and $420 is the principal. 13.32 to the nearest $10, it's going to be 13.30. In question 13, the 1968 Australian 2-cent coin is very rare. If a coin collector purchased one in 2006 for $500, so I'm guessing that's going to be our principal amount, and the value of the coin increases by 20% per year, that's a very rapid appreciation. 20% per year. Calculate the value in 2020, which is going to be in 14 years after the purchase was made. They bought it in 2006, so in 2020 it's 14 years later. Got to make sure our answers to the nearest $10. So N equals 14, I equals 20, PV equals 500, and let's calculate it. 6,419 to the nearest $10, 6,420. Alright, question 14. Gaetano bought a house for $450,000 I think we know what P is. In an area where house prices appreciate an average of 3% per year. He decided to hold on to his house until its value is at least $650,000. How many years should he wait until he sells his current house? Okay, so this one's a bit different. This one we don't know what N is, but we do know what the final amount is going to be. The end result will be $650,000. So let's put that into the calculator and see what we find out. So this time N equals, we don't know. I'm going to leave that blank. The interest rate's 3%. The principal was $450,000, and the final amount was $650,000. We better put negative $650,000. So that's the way the computer likes it. Okay, when we do that, now we click on N because that's what we want to calculate, and we get 12.44. So N equals 12.44, and that's going to be in years. How long should he wait? Well, if he waits 12.44 years, if these values hold true, the 3% per year, then his house will be worth that much money. Question 15. A painting is currently valued at $4,500 and is known to appreciate an average of 8% per year. After how many years would the painting have a value of $25,000? So we want to know N here, and we know the final amount is going to be $25,000. Let's put those values in. So N we don't know, I is 8, PV is 4,500, and the final amount, let's remember to make it a negative, to 25,000. How long will that take? 22.28 years. After that many years, then the value will be $25,000. If they wanted to know how many years to the nearest year or to the whole number of years that would get to 25,000, you can't round this down to 22 years if you want to get it to a whole number of years. You've got to round it up to 23 years, because at 22 years it has not yet reached a value of $25,000. That happens after 22 years. It happens about a quarter of the way through that year. So if you wanted a whole year answer, then it's going to have to be 23 years. After 23 years the value will be greater than that, but at 22 years it won't be at that value yet. So the answer can't be 22. Okay, according to the last sentence, Whitehorse Marsh has a population of 23,600 people. The population increases at a constant rate of 3.5% per annum. How long to the nearest month will it take for the population of Whitehorse Marsh to reach 40,000? So we want to know N, and we've been given the final amount A, which is 40,000 people. Now note that we need to give our answer to the nearest month. So our answer for N is going to come out as a number of years, and we'll need to convert that into months. So I is 3.5, PV is 23,600, PMT 0, and this is negative 40,000. And when we calculate N, it turns out to be 15.34 years. So 15.34 years is our answer, and we need to give our answer to the nearest month. So it's going to be 15 years plus however many months 0.34 years is, and to find that we need to multiply it by 12. There's 12 months in every year, so if we do 0.34 times 12, we get 4.08 months. So 15 years and 4 months. That's going to be our answer. Okay, in this one we've got a 1.25 litre bottle of soft drink. Don't get thrown by that number, it's not important. it costs $1.50. There's an annual inflation rate over the next 4 years of 4%, and it's over 4 years, so the number of compounding periods is 4. We want to know how much it's going to cost. So let's put those values in. N equals 4, R equals 4, and PV equals 150. What does FV equal? It equals 1.75. So that's obviously answer C. Okay, in part B, we've got another question. What is the amount rounded to the nearest hundred to be invested for 6 years and compounded semi-annually, that's important, at 8% per annum? The value of the investment at the end is 15,000. So this time we don't know P. We know that N is the amount of time is 6 years, but it's compounded semi-annually. That means twice every year. So N is actually 2 times 6, which is 12. Twice every year for 6 years is 12. And the rate is 8%, and the amount at the very end is 15,000. So if we put those values into the calculator, N is 12, I is 8%. The final amount is 15,000, and the number of payments per year, we've got to change those to 2 because it's semi-annual, it's happening twice every year, so we change these to 2, and then we can calculate the initial amount, and it must have been 9,368. That was what we must have had at the beginning. To the nearest 100, it's going to be 9,400. So we'll get rid of that. 9,400 is what we must have had at the beginning, which is answer B. Okay, finally question 18, we've got to find the annual rate for the following investments. So they've given us all the amounts all nicely set out here, and all we've got to do is put them into the calculator and get our values for R. So for the first one, we've got the the end amount for the first one is 8,800. The initial amount was 8,000, and the number of years was 2. So we'll change those back to the standard 1, and we've got to remember to make our final value a negative number, otherwise it won't be able to calculate it, and we get an interest rate of 4.88. So for this one, the interest rate must have been 4.88%. Okay, for the next one, we've got number of years is 6. So 6 years, the interest rate we'll find out. The initial value was 50,000 and the final value was 62,000, negative 62,000. And we get an interest rate of 3.65%. Okay, for the next one it was 5 years. We don't know I. The beginning value was 16,500 and the final value was 24,000. So I must have been, got to make it a negative, I must have been 7.78. And finally, the last one is N is 3 years. I is unknown. The initial amount was 15,000 and the final amount was negative 15,700. 1.53. And there we go. All done. Thanks for watching the video.